Hi, this is Sharon Sarago. Today we're going to be talking about sets and unions. So first of all, we want to know what some terms mean. We have union, intersection, elements. All of those things we have to know about. A set is a collection of things, usually numbers, which is denoted by these parentheses in math. For example, let's call set A 1, 4, 7, 11, and 13. And then set B would have the numbers 2, 3, 7, and 15. We could be asked to find the union of sets A and B, which is the combination of the two sets. So the union of set A and B would be all of those numbers together. 1, 2, 3, 4, 7, 11, 13, and 15. Just note that each element of A and each element of B is in the union. When you list the elements or members in a set, you don't need to list any duplicate members. In our example, the number 7 is in both sets, but it is listed only in the union one time. When working with two or more sets, the elements that are the same in both form the intersection. So for set A and set B above, the intersection of set A and set B would be 7, because 7 is in this one and 7 is that one. And so remember, when you're working about the intersection, you want to look for elements that are the same in both sets. Let's look at some problems. We have set X, which is comprised of 1, 2, 3, Y is 1, 3, 5, and set Z is 1, 5, 10. What is the smallest sum that can be obtained if three different numbers are selected, one from each of the sets above? Alright, well, if we started here and we used 1, then we can't use 1 here, so we'd have a 3, and we can't use 1 there, so we would have a 5. So why not start here and go backwards? So if we start with the largest set, then we know that Z is equal to 1, Y would be 3 since we've already used 1, and X would be 2 since we've already used 1 and 3, and they said they had to be different numbers. So what would be the sum of that? 6, of course. Using the sets X, Y, Z from number 1 above, what is the largest sum possible to obtain? So clearly we want to use 10, and we would want to use 5, and we would want to use 3. Those are our three largest numbers in each of the sets. And so, of course, our sum then would be 18. Another question. Set A has A members, and set B has B members. Set C consists of common members of both A and B. Our question says, which of the following represents the number of members not in C? And there are choices. All right, well, it's easier to see this if we have a Venn diagram. So over here, set A is there, set B is here in the yellow, and there are some common members. And set C is part of A, and it's also part of B. So when we are trying to find the number of members not in C, we're just looking for this portion and this portion. In order to get that, though, we're going to have to say A minus the C and then plus B minus C. So if we have A plus B and we have two C's, we would have A plus B minus 2C, which would be choice D. All right, the next question. Let N be the set of negative integers, F be a set of multiples of 5, and E be the set of even integers. All right, so they want to know which of the following numbers will be a member in all of these three sets. Well, if N has negative numbers, we know that our number would have to be negative. If F has multiples of 5, then it would have to be 5, 10, 15, 20, so on and so forth. And E is a bunch of even numbers. So, of course, we can now get rid of the 5, the 15, the 25, because it has to be even. Here are our choices. We want one that's negative, so we're down to 2. It has to be a multiple of 5, that's both of them. But on E, it has to be even. That would give us choice A. Another question. The set P is made up of all positive integers that can be written as n squared minus 1, where n does not equal 0 and n is an integer. Which of the following is not in set P? Well, if set P is made up of all positive integers, positive integer, positive integer, positive integer, positive integer, why is this not? Because, remember, 0 is neither negative nor positive, and so A would be our answer. And it's just right there in your answer. You just have to think about it because this is a lot of logic problem. Here we've got 50 students were surveyed on whether they like to skate or swim, and the results are graphed above. There's a diagram for us. How many of the students surveyed did not like to skate or swim? Okay, so we have 13 like to swim, 12 like to skate, and 10 of those like to do both of them, swim and skate. So part of your number of swimming is tied up in here, and part of your number of skating is tied up in there. So let's see. Oops, went too far. I'll tell you what, you do that one at home, and then we will talk about it when we meet again on our meeting. Here we've got set A contains all integers. Set B contains multiples of 3 larger than 6 but less than 18, and we want to know how many members are in this intersection of sets A and B. So here we've got set A, all odd integers. Now we could have gone ad infinitum, but we also know that set B contains multiples of 3 larger than 6 but less than 18. So it wouldn't do us any good to go any farther, because if we're looking for an intersection of sets A and B, we're not going to be able to go over 18 anyway, so we don't even need that one. And so then set B contains multiples of 3 that are larger than 6 but less than 18. Well, here we have some larger than 6 but less than 18. Multiples of 3, so we've got 9, 12, 15. We can't go up to 18. And they want to know how many members are in the intersection of A and B. So basically, we're looking at the numbers that are the same. So we've got 9s are the same, and do we see any others? The 15s are the same. So we actually have 2 that are in the intersection of sets A and B. That would be choice B. Next question says, in the sets described in problem 7, what is the sum of the intersection elements? This question is just simply trying to find out if you know what intersection elements means. So 9 plus 15, that's all you have to do is add that. At the pep rally, 25 students wore the color red, 35 wore the color black, and 10 wore both red and black. Again, you want to set up a Venn diagram so we can see that 25 wore the color red, 35 wore the color black, and 10 wore both red and black. The nice thing is they've just told us we have 60 students. And we want to know how many of the 60 students in attendance wore neither red nor black. So let's just look at this for a second. If we have 25 that wore red but 10 that wore black, then we actually have 15 that wore only red. Okay? So let's see if we can just put this up here somewhere. So we have 15 down here, 15 that wore only red. And then we had 35 that wore the color black, but we have 10 there. So if we say how many wore just black, then we would have, minus that 10, we would have 25 that wore only black. Okay? So let's add those up. We have 15 that wore only red. We had 25 that wore only black. And of course we had 10 that wore the red and the black. How many is that? That's 10. Carry your 1. That's 50. But they said we had 60 students there. So if I have 60, and I've already accounted for all of these, minus 50, I have 10 extra students who wore neither red nor black. Okay, so those are some of the problems that we have, and your exercises are going to have a whole bunch more. It looks like we've got another example here too. We've got a set with 2, 3, 4, 6, and 12, and it says each number in set X above is to be multiplied by 3, and the remaining 5 numbers will make up set Y. All right, so we're going to multiply 3 times each one of these. That would be 6, 9, 12. Here comes set Y, right? 3 times each one of these. And then the next question says, how many numbers will sets X and Y have in common? Well, how many do we have in common there? We've got I did this incorrectly. This number right here is supposed to be a 6. So let's just fix that real quickly. Okay, because 2 times 3 is not 3, it's actually 6. So we have these in common, and 12 is in common, and so our answer must be that. Okay? And then let's see if we've got one more to go in here. Let A be the set of 9 consecutive odd integers whose sum is 27. And let B be the set of 5 consecutive odd integers whose sum is 45. So we want to know how many numbers do sets A and B have in common. Let's just look at this. If I have 9 consecutive numbers and their sum is 27, 9 consecutive numbers, odd integers. Even if I had 1, 2, 3, 4, 5, 6, 7, 8, 9, I certainly would have more than 27. So what I have to do is have some negative numbers here. So this negative number here will knock that one out. Let's just mark them off. Okay? So this 5 right there gets canceled by that. The negative 3 gets canceled here. The negative 1 gets canceled here. And so actually what I'm doing is looking for 3 consecutive odd integers that equal 27. And then I just kind of go backwards and put the negative numbers to cancel those other ones until I have met the criteria, which said 9 consecutive odd integers. All right. And then we have set B. It says it's the set of 5 consecutive odd integers whose sum is 45. And so I'm just trying to start. It's all trial and error. You just start somewhere and start adding up these numbers to see what combinations you have that will make 45. And then they want to know which numbers do these sets have in common. And so we've got, let's see here, it looks like we've got the 5s are in common, the 7s are in common, the 9s are in common, and the 11s are in common. How many? 1, 2, 3, 4. 4 of them in common. Okay? So what's going to happen, here are your answer for those. You're going to have several more of these kinds of problems in your exercises that you're going to print. Do them all, and the ones that give you trouble you want to mark so that when we meet on our meetings, then we can go over those particular ones. Just remember, this kind of stuff is more logic than anything else. So look at it with that in mind, and maybe it'll make it easier. And I will see you in a couple of days so that we can talk about it. Thanks. Have a good night.